So I found yet another practice problem for us to do together, number 29. Continue exploration of the fundamental theorem of calculus. Part 1 in particular here. I'll read the directions. It says find the derivatives in these exercises, but we're going to do 29. Part A, by evaluating the integral and differentiating the result. And then in Part B, by differentiating the integral directly. Now, what do they mean by that? They mean fundamental theorem of calculus, Part 1. That's what they want you to use. And I'm actually going to do Part B first, and then I'll go back to Part A. So if you recall the fundamental theorem of calculus says if I had the derivative of the integral of some constant to x of the function, and here the function, by the way, is cos, let's say cos, and we do have a constant, 0, so if some constant to x of cos t dt, if that was the case, it's like the derivative and the integral cancel each other out with respect to x, and you almost just looks like you evaluate the function at x then, right? So your final answer would be cos x. So a lot of people say, oh, okay, so differentiating the integral sends you back to the integrand. Yeah, sure, but notice the upper bound is x. Here, the upper bound is not x, it's root x. I rewrote it on the next slide, see? So you say, all right, maybe it's not quite as simple then. No, it's not. It's not quite as simple. So let's let u, got to perform a lovely little u substitution. Let's let u equal root x. Then du would equal what? 1/2 x to the negative 1/2. Okay, bear that in mind. Now, what we can do is re-express the original, meaning let's try and differentiate with respect to u instead. Okay, so now what if we were interested in d du on the bounds from 0? And by the way, notice if you store 0, I just do want to make a note of that. Notice that the root of 0, when you're doing your bounds, you want to double check this, but notice that the square root of 0 is still 0. Okay, so your lower bound's still 0. Notice root x was that u, so we're re-expressing the original in terms of u, basically. So now we've got d du, integral 0 to u, of cos t dt. Now, the fundamental theorem of calculus would lead you to believe that, okay, differentiating the integral is just going to sort of cancel itself out, and we'll just store u in and we'll be fine. Right, so it's not quite that simple. So cos u, but then you have to chain rule it out, and there's the tricky part. Times du, and I should say this here was du dx. So cos u times du dx. You have to chain rule it out because u was a function of x. So, when you're differentiating something that is like a composite function, you got to use the chain rule. So note to self, chain rule. So it wasn't just as direct substitution. We had to use the chain rule there. Now the thing is, that's beautiful, but it's still not totally with regard to x. So cos u du dx. Now go ahead and sub back, everything that you know. Okay, so I wanted to move to another slide. So here we are at d du of integral of 0 to u of cos t dt is cos u times du dx. And then in the next slide, cos u du dx, we're ready to put things back in terms of u, and I'm going to highlight this in another color. U had equal to the square root of x. Okay, so now I've got cos root x, and du dx was equal to, 1/2 x to the negative 1/2. And that would be your final answer. Now the cool thing is we did that by the ftoc, by the fundamental theorem of calculus. We basically did part B. Now what happens if you were to actually integrate, because notice what it says the derivative of the integral of the function. So what if you actually took the integral of the function and then differentiated that result? let's experiment with that. So we should do that for grins and giggles, meaning you shouldn't just believe the fundamental theorem of calculus, even though it is hundreds of years old. You should experiment with it. So let's go ahead and integrate. What is the integral of cos? Hopefully you're thinking sine. So we'll go with sine of t, and we'll bound that. So in other words, we're going to zoom in on performing the integral, and then we'll eventually differentiate the result. Okay? So sine of t, we're going to go ahead and bound that from 0 to root x. Oops, I should say root x. Okay, now we're going to grab root x, store it in place of t. All right, then we'll have sine root x. And now we're going to subtract. Now grab 0, store it in place. So subtract sine 0. All right, well, that should say 0. Sine of 0, let me grab a different color. Sine of 0 is 0. So that's just going to 0 out. All right, so after all that sweat equity, we arrive at sine root x. But now, look at what we have to do with that result. Now differentiate that result. Note to self, now differentiate this. Okay, sine, so d dx of sine of, what was it, root x? Remember, that's going to involve the chain rule. So what's the derivative of sine? Cosine. So we'll have cosine root x. Chain rule that out, so then times the derivative of that inner core. So what's the derivative of root x? Well, 1/2 x to the negative 1/2. Aha. Now the aha moment. Looky here, looky here. So if you integrate and then differentiate, you're going to get the very same result. Let's look at that, and let's back a couple slides. Hey, that's the very same result. Cos root x, 1/2 x to the negative 1/2. Cos root x, 1/2 x to the negative 1/2. Some people might say, yeah, but that was easier that way. Right. Depends on the problem. Okay, hope that helps.